Hello everyone and welcome to the class. We have been doing the chapter known as states of matter, gaseous and liquid. So far we have covered the first law of gas, that is the Boyle's law. Today we are going to cover Charles' law. Scientist Charles studied the relationship between the volume of the gas with the temperature of the gas, and he found some of the observation. He then, the observation that he got, stated in the form of a law known as Charles' law. It is saying that at constant pressure, the volume of a certain amount of gas is increased or decreased by 1 273 part of its original volume at a 0 degree Kelvin, 0 degree Celsius temperature, with each rise or fall in the temperature. Now, what that's mean is that supposedly a certain amount of gas is taken, and the volume of that certain amount of gas at 0 degree Celsius temperature is found to be, let's assume, at 0 degree Celsius temperature, volume of gas is V naught. Now, according to the Charles law, with 1 degree Celsius increase in temperature, the volume increase is equals to the original volume at 0 degree Celsius, that is V naught, multiplied 1 by 273, that is V naught by 273 amount of volume will be increased after 1 degree Celsius temperature increase. If T degree Celsius temperature increased, therefore for T degree Celsius temperature increase, the volume will increase to V naught 273 is the volume increase for 1 degree Celsius. For T degree Celsius, it will be V naught by 273 multiplied T. This is the volume increase for T degree Celsius temperature increase. Therefore, the total volume, the new volume at T degree Celsius temperature will be Vt equals to V naught was the initial volume at 0 degree Celsius and plus volume increased after T degree Celsius temperature increase, that is V naught by 273 multiplied T. This is the total amount of volume, total amount of new volume after T degree Celsius temperature. By doing a little simplification, we can find that Vt equals to V naught whole into 1 plus T by 273. This is the expression for the new volume that we can get on the basis of the Charles observation, on the basis of the Charles law. When T degree Celsius temperature is raised, if T degree Celsius temperature is decreased, then the expression will be T naught equals to V naught whole into 1 minus T by 273. So in general, we can say that at 0 degree Celsius temperature, the volume of a certain amount of gas, if V naught, in that case, with the temperature increased to or decreased to T degree Celsius temperature, the new volume, the expression of new volume will be Vt equals to V naught whole into 1 plus or minus, depending on whether the temperature is increasing or whether the temperature is decreasing, that is plus minus T by 273. This is the general expression for Charles law. So at the end, what we can say that Charles observed the variation of volume with respect to the variation of temperature for gas, and he observed that it the volume of the certain amount of gas is directly proportional with the temperature. If temperature increases, volume also increases. If temperature decreases, volume decreases. He also calculated the amount of the volume that will be increased or decreased with the rise or fall in temperature, and he found that for a certain amount of gas, the volume will increase 1 by 273 times the original volume of the gas at 0 degree Celsius temperature. And he formulated a expression on the basis of this observation, and the general expression is V naught equals to Vt is equals to V naught whole into 1 plus minus T by 273. Charles' law can also be explained on the basis of graphical explanation. The graphical explanation as Charles' law relate the volume of the gas with the temperature. That's why we are going to take the y-axis as the volume axis and the x-axis as the temperature axis taken in degree Celsius. Now, the Charles law expression Vt equals to V naught plus V naught by 273 multiplied T. This is the expression that we are going to take help for to establish this graphical plot to explain the Charles law. Now we are graphically plotting the versus T plot. V is the y in this expression. V naught is the constant C plus M is the V naught by 273, the slope, and T is our X. So this is a straight line equation starting with an uh, initial point C. So this will look like this with a slope M, which is representing the V naught by 273. Now this is the graphical plot for the Charles law expression, mathematical expression. But if you extrapolate this plot and then extrapolate the plot till a point 0 where the volume becomes 0, you will reach a temperature. This is 0 degree Celsius temperature because the temperature that we had taken in degree Celsius term. So when you extrapolate the plot to a V equals to 0 magnitude, you will reach a certain temperature which will belong to T equals to minus 273 degree Celsius. 273 degree Celsius. This temperature is known as absolute temperature, at the temperature at which the volume of the gas becomes 0. This is a hypothetical temperature because in nature it is found that before reaching this temperature, way before reaching this temperature, gases solidifies. So the gas law is not applicable at this temperature to actually find out the volume of the gas 0. So this is a hypothetical temperature that cannot be attained, but mathematically it can be attained and it is known as absolute temperature. The mathematical expression for Charles law is when T degree Celsius temperature rises, the new volume Vt is found to be V naught whole into 1 plus T by 273, or Vt by V naught is equals to 273 plus T divided by 273. Now we know that 273 is the base value for Kelvin temperature, and 273 plus T is the temperature related to the at Kelvin scale for the T degree Celsius temperature. So in turn we can say that the volume of a certain amount of gas is 0 degree Celsius temperature is V naught, and the temperature at at Kelvin scale is 273 Kelvin at 0 degree Celsius temperature, and at T degree Celsius temperature the volume is Vt, and in Kelvin scale, at Kelvin scale, the T degree Celsius temperature represented by 273 plus T Kelvin. Therefore in turn you can say is that V naught by Vt is equals to T of T by 273. That is the temperature at Kelvin scale corresponding to T degree Celsius, or V is directly proportional to T at Kelvin scale. This is the alternate equation, mathematical equation for Charles law, that can be written as V1 by V2 equals to T1 by T2. And the statement can be written as, and at constant pressure the volume of a certain amount of gas is directly proportional with its Kelvin temperature. The alternate statement of Charles law can also be explained on the basis of the graphical explanation. The first explanation, graphical explanation, that we will do is the same of that was the before, that is V versus T plot. Now the expression of a alternate statement for Charles law is V is directly proportional with the absolute temperature. To remove the proportionality sign, or to replace the proportionality sign with the equal sign, we need to do that V equals to proportionality constant K multiplied T. K multiplied T, and thus we can get the expression, that is V by T equals to K, that is constant. Now to plot this graph, we are going to take the help of this particular expression. Let's draw the plot. This is the y-axis and this is the x-axis. The y-axis is going to be the volume axis and the x-axis is going to be the temperature axis, but in this case taken in Kelvin scale. Now the mathematical expression is V equals to KT. V is the y-axis, equals to K is the constant, or in this case a slope, and T is the x. So this is nothing but a straight line equation starting from origin. So this will be the a plot representing a straight line equation representing the slope, a positive slope, and this point representing the 0 Kelvin temperature. Now 0 Kelvin temperature is nothing but minus 273 degrees Celsius at Celsius scale. So the previous graph that we had studied, this one, where we were doing the V versus T plot, the temperature taken in Celsius scale, the plot that we were doing, where by extrapolating we were getting the 270 minus 273 degrees Celsius temperature. The this plot and the above plot are in fact actually the same kind of plot, just the V axis, the volume axis, has been taken from the minus 273 degrees Celsius temperature instead of the 0 degree Celsius temperature for Kelvin scale. So this is the same kind of plot, just the position of the volume has been taken from the minus 273 degrees Celsius temperature compared to the 0 degree Celsius temperature for Kelvin scale. Just like Boyle's law, Charles law also is applicable for low temperature and high pressure. Most gases follows Charles law at low pressure and high temperature. Now from the Charles law also we can relate density with the temperature. The mathematical expression for Charles law is V equals to proportionality constant K multiplied T. Now we know that V equals to mass by density, K into T, as density equals to mass by volume. So from this expression we can find out from this expression we can find out as density equals to mass by volume. From this particular expression we can find out that volume equals to mass by density, and by substituting the value volume in the main equation with m by d equals to kt, we can find this simplification. So by doing that we can have that d equals to k by m, sorry, m by k whole into t. Now this entire Gash law is we are observing this entire Gash law in a closed container. We had just talked about this earlier. At a constant pressure, as this is a closed container, the amount of gas that we are observing are constant for throughout the observation throughout the experiment. So the total mass of the gas will also going to be constant, and m represents the total mass in this expression. So as the total amount is constant, this total mass m is also a constant. So this entire term m by k is a constant term which is relating the density of gas t with the temperature in this form. D density is directly proportional with the absolute temperature T. Sorry, a little bit of a mistake I had made again. This is going to be 1 by T. 1 by T. Density is inversely proportional with the absolute temperature. That is, if absolute temperature of a gas is increased, the density of the gas will decrease. If the absolute temperature is decreased, in that case density of the gas will increase. That the gas are found to be more dense at low temperature and less dense at higher temperature. Gay-Lussac's law relate the pressure of the gas with the temperature of the gas, like the Charles law relate the volume of the gas with the temperature of the gas. This statement is saying that at constant volume, the certain amount of gas, the pressure of a certain amount of gas is directly proportional with its absolute temperature. That is, if at constant volume, a certain amount of the pressure of certain amount of gas is P, in that case it is directly proportional with the T, or it can be written as P equals to K into T. K is the proportionality constant. So to graphically plot this, you can take P versus T graph, where P is representing represented by the y-axis, and absolute temperature T is represented by the x-axis. Now this is also a y equals to mx kind of a straight line equation starting from origin. So the plot will look like this, and this can also be written as P P1 by P2 equals to T1 by T2. This is the Gay-Lussac's law. Now there is a fourth gas law that we are going to study is the Avogadro's law. Now Avogadro's law relate the last two remaining physical parameter, that is with the volume of the gas with the numbers of moles of the gas. Now these two physical parameters we are discussing, therefore the remaining two we need to take constant, that is the temperature and the temperature and pressure. Now little bit of a mistake I had done. That is, at constant temperature, at constant temperature and pressure, the volume of a certain amount of gas, the volume of a gas is directly proportional with the numbers of mole present in the gas. Now, as at different part of the world in different condition, the temperature and gaseous volume depends on the temperature and pressure. That's why for the observational purpose, for the ease in our observational power purpose, two parameters have been fixed throughout the world, that is the temperature and pressure. That is, the temperature is taken 0 degree Celsius as the standard temperature, and pressure 760 centimeter mercury, 760 of mercury is taken as the standard pressure for the observation of gas. And depending on this Avogadro's law, an observation has been made that at a 0 degree Celsius temperature and at 760 C millimeter of mercury pressure, 1 mole amount of all gas possess same value of volume, because Avogadro is saying that if the temperature and pressure is fixed, then in that case the mole numbers will be proportional with the volume. The amount of mole present in a gas will have the same amount of volume irrespective of what kind of the gas you are talking about. That's why these two temperature is known as this temperature and pressure is known as the absolute, is known as the standard condition. So it has been found that at STP, standard temperature and pressure, which is 0 degree Celsius and 760 of or 1 atm pressure of Hg, 1 mole of all gas have 22.4 liter volume. At STP, that is 0 degree Celsius temperature and 760 of mercury, 1 mole of all gas have 22.4 liter of volume irrespective of the gas. Now 1 mole is nothing but 6.022 into 10 to the power 23 numbers of particle of gas. Therefore, in turn, you can say that at a 0 degree Celsius temperature and 1 atm pressure, 1 mole or 6.022 into 10 by 23 numbers of particle of gas occupy the volume that is equal to 22.4 liter. Boyle's law, the mathematical statement of Boyle's law is saying that V is inversely proportional to 1 by P when temperature is constant for a certain volume of gas. For a certain amount of gas, for a certain amount of gas. Charles' law, on the other hand, is saying volume is directly proportional with the absolute temperature when the pressure of the gas is constant for a certain amount of gas. Now, when both temperature and pressure varies, we can combine the Boyle's law and Charles' law and can get both temperature and pressure varies. We can combine Charles' law and Boyle's law by T by V. V is directly proportional with T by P, or PV equals to proportionality constant K T. This is known as combined gas law. You can write this combined gas law as this one: P1 V1 by P2 V2 equals to T1 by T2.